Now, today we're going to start by looking a little bit further at area of triangles and parallelograms. This is something that you'll have done in area and volume as well, so we won't spend too much time on it, but it's useful to go over some of the questions, some of the concepts that are here. So the first thing to write down is our formulas, that the area of a triangle, is half its base multiplied by its perpendicular height. And we're just going to add on something there. The important thing that we want to add on is that it doesn't matter which side we choose as the base. I think this is something you probably already knew. It's just worth going over it nice and quickly. So if I put in a diagram like this, if I have a triangle, I'm not going to use my ruler, just quickly sketch out a triangle like this. The area can be found using this base and this height, or I could use this base and this height, and I'll get the same answer. So, or I could use this base and this height. Okay, so you can rotate the triangle any way you want and consider that if you have a perpendicular line coming out from one of the sides, then you can use that side as the base in your area formula. So let's do an example with these. First example. I'm not going to do the going forwards example because we just did one in the homework. You all know how to find the area of a triangle filling into that formula. What if they gave us the area? So find the value of h for each of the triangles below. Now my first triangle is going to look like this. And the reason I'm drawing it like this is because I want to remind us, say that that's 5 centimeters, that sometimes the perpendicular height, when we draw it, is outside of the triangle. It's because of how it's leaning. So we call that h. That's h. And I also know that the area of that triangle is 62.5 centimeters squared. Okay, that's the first triangle. And the second triangle looks like this. And I have that this is 6 centimeters down here. And that this perpendicular height, not drawn the best, is 8 centimeters. But wait, I said I was going to find a value of h. Yep, I'm going to do it like this. So this is going to be h, and I'm told that this value down here is 10 centimeters. And that's the second part. So let's answer these questions. For the first one here, we know the area, and we know that area is half the base by the perpendicular height. So we fill into that formula. A half by 5 by h is equal to 62.5. We just do that multiplication. 2.5h is equal to 62.5, and then I can divide across by the number in front of h. Sorry, it went off the screen there. And h is equal to 62.5 divided by 2.5, and that gives me 25 centimeters. So the question specified the units, and we must put them in our answer. Okay, now in the second question, it's a little bit odd. They didn't give us the area, but they gave us a way to find the area. So if I use the purple sides there, I can calculate that the area is a half the base by the perpendicular height, and that's 24 centimeters squared. So because I know that, I can now use the green sides. So the area is also a half by this base, by 10 by h, and I should get the same answer for area when I do that. So I've got 5h is equal to 24, divide across by 5, and h is equal to 4.8 centimeters. Okay, so hopefully that's clear enough. We need to know similar types of information for the area of a parallelogram. The interesting thing about a parallelogram is that it's actually two identical triangles stuck together. So if I draw a parallelogram like this, some properties of parallelograms to just remind ourselves. Opposite sides are equal in length. So those sides there are equal in length. And of course, opposite sides are parallel to each other. And opposite angles are equal in measure. Opposite sides are not only parallel, but they're equal. And opposite angles are also equal. That's a fact that we had from junior cert, but you might have forgotten it. So as I was saying, a parallelogram can be divided into two identical triangles. So if one triangle is half the base by the perpendicular height, and I have two of them, I have 2 times half the base by the perpendicular height. The area of a parallelogram is its base multiplied by its perpendicular height. Let me make that perpendicular height. Let's do a quick example with that. Find the area of the parallelogram below. We sketch a parallelogram. We have parallel sides like this, and we join them together. So if I know that, excuse me, this side is 6 meters long, and if I know that this distance here is 3 meters long, then I can work out the area. It's just the base by the perpendicular height. So that is 6 by 3, which is 18 meters squared. Okay, let's do a quick example working backwards. Find the length of the missing side in the parallelogram below. Okay, so we have a parallelogram like this. And we're told that this distance here is, say, 5 millimeters. And we're told that this distance here is 7.2 millimeters, but we actually don't care. And we're asked to find this distance here if we know that the area is 52.5 millimeters squared. So we'll use our area formula. The area is the base by the perpendicular height. So that means that x multiplied by 5 is equal to 52.5. And we don't use this information. We don't need to use that information. Sometimes there'll be a follow-on question involving Pythagoras' theorem, because you can see that this would make a right-angled triangle here. So if I know this distance, I can find this distance here. There could be a follow-on question like that. Anyway, for this question, and this can happen, you can be given more information than you need to use. So 5x is equal to 52.5, and x, my missing side, is 10.5 millimeters. And that's my answer. Okay, so I'll stop there for this lesson, and we'll go on to the next topic for our second class in a separate video. Thank you.